In this video we are going to see how we are going to read a string over a non-deterministic finite automata. What's actually going to happen when I do this? So I'm going to take the same previous example. So the example was our language was AB union ABA star, means all those strings which are some combination of AB and ABA in any order of any length. We have looked at a non-deterministic finite automata for solving this, which look like this. So definitely my initial state is going to be the final one. Then if I read an A, I come over here. If I read a B, I have two transitions, one which can take me back, so in case I want it to be AB, and one which gets me to another state in case I am trying to read an ABA. So this first loop is for AB and this another loop is for ABA, and now you can keep reading them in any order. Let's now take a string and let's see how this machine will work for that. So let's take this string ABABA, which is quite a simple string, and let's see how we'll read it. Let this state be Q2 and this state be Q3. Okay, now when we read this string, so in a deterministic finite automata, how we read? We stood at the initial state in the beginning. So here also I am standing at the initial state in the beginning, which is Q1. At Q1 I read the symbol A. So on Q1 when I read the symbol A, I come to Q2. So it takes me to Q2. Even in a deterministic automata we were doing this. Now when I read the next symbol B, if it was a deterministic machine, I would go to exactly one state. But in this case, you see, when I am reading B, I can either go to Q1 or I can go to Q3. So what happens actually at this point, the machine breaks into two parts and you can take any possible path. So when I am reading a B over here, over Q2, I can come back to Q1 or I can go to Q3. Now these are two paths on which my machine can go. Next we have an A. I am going to read this A from Q1 as well as from Q3. So if on Q1 I read an A, I come to Q2. If I read an A on Q3, I come to Q1. After A, I am going to read a B. So Q2 on B comes to Q3. Q1 on B. Now if you look at Q1 on B, the transition is not defined. So what I will do in such a case, I will say that this particular path is now dead. There is no, because it's not taking me anywhere, right? So this one path is dead, and then after B I am going to again read an A. So even on Q3 when I read A, I come to Q1. So at the end, if you see, the machine has two possible ways of executing this string. First one is this and second one is this. And the machine is going to accept the string if it comes into final state in at least one of these paths. So you look at Q1, Q1 is a final state. So if I follow this path, the machine comes in a final state. Hence I say this string is accepted by my machine. On the other hand, if we take some other string, let's say ABAA, and you see what happens over this. So Q1, on Q1 when we read A, we come to Q2. Q2 when we read B, we go to two states. One can be Q1, other can be Q3. Here when I read A, Q1 on A comes to Q2, Q3 on A comes to Q1. And when I again read an A, so Q2 on A is dead and Q1 on A is Q2. So you see there are two paths, one leads to dead and other leads to Q2, both of which are non-final states. So this string is rejected by a non-deterministic automata. So this is the way we can execute it.